Hi everyone! Today I want to show you how to use GeoGebra to draw gradient vector fields. So first of all, download GeoGebra Class 6. On the right upper corner, you can choose the view option. So you can choose the 3D graphics. So maybe when you open it, it has the graphics, but deselect the graphics and choose the 3D graphic. Okay? So first of all, let's draw. In order to have a gradient field, we have to define a function. So let's define a function. So let's call f of x, y, z equals x squared plus 2y squared plus 3z squared. Okay, and then enter. So this is a function with 3 variables. And then next, we want to find the partial derivatives. So here we input f sub x of x, y, z equals the derivatives of f with respect to x. So f x. Okay, and let's find the partial derivative with respect to y. So f sub y x, y, z equals derivatives. We choose function f, variable is y. Okay, and then the partial derivative with respect to z equals derivatives function f, variable z. Okay, so we have the 3 partial derivatives. So now let's create a slider for the scale of the vector field. So here in the 3D graphic, you cannot see the slider option. So that's why let's click the view and then let's show the graphic. So in the middle window, you can see we have the option of the slider. So we click the slider and then click anywhere in the middle window. So it's actually tell you where the slider locates. And then let's call A. We want to have A to be the scale. Okay, so let's be 1 to 50 with increment 1. Okay, so this is our slider. Now we can deselect the graphic options and leave the 3D. So now our slider is right here. Okay, so now how do we define the gradient vector fields? So input, so I'm gonna have more space so then I can show you what I input here. So input sequence. Okay, so sequence okay, so we want to have expression and then variable and start value and end values. So we want to have 3 sequence. So continuous sequence, expression, variable, start value, and end values. And one more sequence. Okay. So the first sequence, we want to have the vector. Okay, so this is vector start points and end points. So start point is, oops. The start point is STU. Okay, so STU, and the end point is STU are our variables plus 1 over A times a vector. The vector is f sub x of STU, f sub y of STU, and f sub z of STU. So, okay. and vector. So first of all, I want my variable to be s. My s goes from -2 to 2. Okay, next I want my variable to be t. It goes from -2 to 2. Last, my variable is u. It goes from -2 to 2. Okay, so this is the vector field we get. So if we increase a and z, then we have the smaller vector. So let me make a little bit bigger. Okay, so this is our vector field. Okay, and this is the gradient field of the function f. And we can have the scale. Oh, it's so big. Okay, this one looks nicer. And so right now, let me show you how to draw a vector field in general. Okay, so let's deselect everything here. So first of all, we want to input 3 coordinate functions. So let's call p of x, y, z. Let's call, this is the coordinate function x. So let's call it 2x plus 1. We can make it any general. And q, so q of x, y, z. Let's call it xy. Okay, so and r, x, y, z. Let's have it be z plus 2y. So any function. So we have 3 coordinate functions p, q, r. So next, how do we construct a vector field? Okay, sequence, expression variable is start by n values, and another sequence, and okay, oops, sorry, and another sequence. All right. Okay. So what is the expression? Okay, vector start point is, okay, so change the start point to be STU. And what is the endpoint? The endpoint is STU plus the vector. We want to have 1 over a be the scale, and times PQR. So P of STU, Q of STU, and R of STU. Okay, so, and what are the variables? So we have the variable s goes from -2 to 2. We have the variable t goes from -2 to 2. If you want the region to be larger, you feel free to change your variable stu. And then the last variable u is from -2 to 2. Okay, so this is our vector field. See, we can change the a as well, and oops. Okay, so we can change the a as well. So you can see the arrows and the vector field. So in this case, you can play with it. You can change your coordinate function to be anything. So if I change to yx, so you can see it changed it a little bit. So in general, you can put any function, any coordinate function, PQR, then you can get this is the vector field. Okay, how do we share this project to public? So on the right upper corner, there's 3 horizontal lines. We can click File and we click Share. So first of all, you gotta log in using your Google accounts or Microsoft accounts, and then make sure you click the shared options. Otherwise, other people cannot open your link. So how do we call it? Let's call, this is Calculus 3. Calculus 3, we use GeoGebra to draw gradient vector fields. Oh, actually, we not only draw gradient vector field, we draw in general any vector fields as well. Okay. All right, we click Save, and it says saving. Oops. Oh, I just saw a link pop up and then okay, let me do it again. Oops. So sorry, I should shared. And hopefully okay, so here's the link. So then go to any web browser and enter. Loading. Okay, here is our projects. So anyone with your link can see your projects. Okay, so thank you for watching. Have a nice day.